Good to know. Yeah. 4:30. Let me just double check that. This is. Test. Okay. Should be okay. Should be good. Should be good. We're going. So everybody have Godot downloaded? Give people a few minutes to open this.
Oh, yeah, it's open. Yeah. No, that's just how you punch. There's no like installer. Nice. Has to be in the state. I'm going to post a separate video about version control for the different names. So if you want to break out a name.
Let me know when we're good, River.
It's in the setup guide for all the things. That's all long. But yeah, you're pretty much good with quality. Yeah.
All right, we ready? Okay.
Oh. Yeah. You'll see two files, console and then one without console. Just run the one without console. You can click run. More info. Create the project. CSU.io. Did you put that in the Discord?
Oh,
Let me find and start.
all right. Everyone on there?
Got it in the Discord.
Thumbs up? Yeah, it's in the Discord.
You all got it. Hold on. It's in the scene. But in general.
Yeah.
Yeah. One has.
Sweet. Now we can begin. So going here, I want to let you know that everything that I wrote in here is what I'm going to be covering in the workshop. So if you'd like to review anything, it's going to be in here. But this is downloading Godot. What the first thing we're going to do is go here and download the assets. We're going to open this link, download this, and we can unpack that. So let's launch Godot, run it. We're going to hit create. We can call this, I don't know, my first game.
Dim the lights,
If you'd like,
what do they dim or do they just come out?
let's see. It's bright enough in here.
Okay.
Pay attention to whatever path it puts it in. If you want to put it somewhere else, you can do that. Forward plus is fine. All this is good. We hit create.
Yeah.
Okay, so first thing we are going to do is we are going to take the four files that are in the assets and we're going to drag them into the file system. All of that's going to import, and it should look something like this. Sorry. Do you want me to recreate the project? Okay.
Well, I see it in one draw, trying maybe creating a house. Things like the top arrow with break. And
So yeah, I'm gonna make a new project, start over. I'm calling this one my first game 2. We hit create. Go here. We have the 4 assets that we got from the zip file. We're going to select all of them and drag them into this bottom left window onto the resource folder. Everyone still with me?
the app.
I got them from this page from the workshop under making a game. You click here, and then you get them here. River, do you mind just like watching everyone from behind and like when everyone's about where I'm at, telling me to go on?
Yeah.
Okay. So first thing we're going to do is part of what Godot does when it imports the assets is for images. it automatically compresses them. This is because typically in video games, you're going to use very high resolution images, and those are a lot of pixels to store in the GPU. But for this project, the assets are pixel art, which means you can see stuff like, better example if I open the model. So there's supposed to be clean borders here on the oil canister, but because of the compression, some of the colors are bleeding over. And in the player character, we can see some of the borders here are uneven just because of how the pixels are being compressed. So what we need to do is for each of the images here, we click on the image, go up to the import tab, and change the mode from VRAM compressed to lossless. And we do that for all 4 of the images. All 5. That's all right. Okay. So now if we go back to the model, we can see that all the borders here are clean.
It's not needed, sorry. Oh, yeah. They need to change it for PNGs too.
All PNGs.
One of them, nothing comes up on the import.
Which file? This one? So this isn't showing up for you?
For some, go download it, it's on losses by default other times. If you want. Everyone else good? Yeah. All right, so.
Next, we are going to create the scene. So we're going to hit 3D scene because we're going to make a 3D game. And we're going to rename the node by double clicking it, and we'll call it something like level 1. Cool. Now we are going to make, we're going to add a child node. And we are going to make it, so just to review, we are going, that's going to show up every time I hit escape. So we right click this, add child node, and we are going to make a node 3D. So the way Godot works in its scenes is everything is made up of nodes, and nodes can be children of other nodes, which means that anything that happens to the parent node reflects in the child node. So for example, if you have a player that's like a physics object, the child nodes would be maybe a mesh to render it, a collider to define its shape in the physics engine, things like that. And we'll get to that in a bit. But this is the basic structure of Godot. So we're going to rename this node to map, and this will contain everything that belongs to the level, essentially. Under this one, we are going to create what's called a CSG box. And a CSG box is essentially an all-in-one object that has collision. It renders a cube. It's really good for prototyping levels when you just need to throw something together quickly. This would be useful in, say, the game jam, but for bigger games where you would need a more permanent solution, these generally don't scale well since they don't perform the best on computers. We right-click, add child node, type CSG, and we select the CSG box. Got it? Okay. So, and make sure this is a child not just of level 1, but of the map itself, because we're gonna have all the level geometry in here. So we can take this, there are 6 handles that we can expand it by. We can hold Alt to expand it symmetrically, and we can hold Control to snap it to intervals. So in the bottom left of the window, right down here, we can see the size. So I'm just gonna make this 32 by 32. I'm gonna go back up here. I'm gonna hit Control D, and that's going to duplicate it and make another box. So here we have another one. I'm going to shrink it again. Make it a little bit taller. Put it here. We'll hit Control D again. Put another one over here. Maybe make it a little flatter. Hit Control D again, and we'll make a third one and bring it right up here. And you can arrange the boxes however you like. This is just the little selection I'm going with to show off the camera and platforming elements we're going to add.
Let's slow down for a minute.
All right. So yeah, just create a few CSG boxes and shape them how you'd like.
It's the platform, right?
Yes. Um, for an external mouse, you would hold right click and use WASD to move around. You might have to do a 2-finger click on a trackpad.
It's like dragging around. It's like literally static when she tries to like click and drag instead of it moving around the scene. It's highlighted.
You have to hit exactly on the orange handles. Are you hitting them exactly?
She's like trying to rotate,
Oh, rotate them?
not rotate them, rotate the camera. If you can, if you want to come see for yourself.
Sure.
I'm not as familiar with using the editor. I don't think that. So we can. Oh. We can try to train with that.
You have to hold right click. On the ThinkPad is a dedicated button.
Oh.
If it's not, then you might have to do 2-finger click.
This is like showing in 2D now. In 3D, but now it's changed to a 2D.
Are you in the 2D tab up top?
No, I'm in 3D tab.
He's in the 3D tab.
Click the button that transformed it orthographic. I think so. Yeah, I'm not as used to the 3D editor, so I don't know. Yeah, don't click on it. It seems like you got. Okay, cool. So yeah, right now we're trying to think about platforms for a platform. Okay, let's do. It full falls, and it sizes symmetrically. So you can also edit those numbers. Yeah. Low. Yep. So. Keep going through eventually on the other side. So keep going through it. And you're on the line right now. Oh, you know what? You set the right height for this is my height. So set that at 170. And you don't need the other. I just want to know that.
Okay, back on track. So we have our boxes. The next thing we're going to do is we need to actually enable collision for these. So we need to go through each one. I should have had you do this for the first one so it would carry over when we duplicated, but go to the first box, check use collision, and we're just going to go through all of these. If I had you do this on the first one, then every time we duplicated, it would have copied that. But now that we have that, let me know when everyone's got that. All right, so after we do that, we are going to take our tile.png and drag and drop it onto the platform. And as you can see, it is filling the whole surface, which is not what we want. We want it to be made of many different tiles. So the way we do that is by going to, we click on the one we added it to. We go to material override under geometry. Click on that, click on the drop down. Under, it's going to be UV1. We hit triplanar. And that should tile it. But if we zoom in, we can see it's still really blurry. What we need to do there is go under sampling and click on nearest. And that makes the tiling crisp. finally, we can see that it's being cut in half vertically here. So we can go under offset. I believe we can add 0.5 and that pushes everything in place.
Then comes up, you got the check a box stats that. So I think you went to this one, whichever your. Oh. Then we need. Then we need to keep on. Just like this. Yeah. If you repeat the steps again for.
So we click on the CSG box that we dragged the tile onto. We go under geometry instance 3D, geometry. And the two sections under here, under the material override, are going to be UV1, where we select triplanar, sampling, where we select repeat, and 1/3 one, we set the offset here to 0.5.
The other got a triplanar on, 45 offset, and then.
Repeat under sampling.
Repeat.
It's going to be under the sampling section, not UV1.
Got repeat on, but it's not doing it on.
So if you have repeats off, oh, that's actually interesting. Okay, so if I reset everything in sampling, wait a minute. Oh, I'm sorry. Repeat is on by default. It's triplanar. What you're changing here is the filter to nearest. My bad. Wrong setting.
We got it.
Do you have triplanar selected?
I believe.
Under UV1, not UV2?
Oh, it's under UV. In. there anything you have to do to make UV1 appear? UV1's not showing up.
Did you drag the tile PNG onto? And you went under material override?
Oh, yeah, period. Click on like the actual. Okay, yeah, I always get thrown off by that design course. Okay, UV1, right? Offset 0.5 offset 7 squat. Then, okay, right,
Everyone's caught up? River, should I move on?
okay.
All right. So to not have to repeat doing the same process for these three, we can right click this material, click save as, and we can call this something like tile. And this is going to save this as a material that we can just drag into the material override for each of these. And it looks like this box here is getting cut with the tile. So I'm just going to go in and right click this. And this will only, and you only have to do this for ones that are not lined up with the rest. Right click, make unique, and then set the UV1, set the offset back to 0.
Right. Yeah. Scroll up, the little arrow. Do anything other than dragging on real, right?
So I didn't drag tile.png into material override for the others. What I did for this, instead of having to redo the work of setting all these settings for all the other blocks, I right clicked the material, hit save as, and then that saved the material down here. So I could drag that into the material override for the rest of them.
Okay. Very good.
All right. So next we are going to we can actually add a camera. So we're going to go back to level 1, hit add child node, type camera 3D. And here we can see the view of it. I'm gonna bring it up. Pull it back a little bit. It doesn't totally matter where we put it right now. I'm just going to put it here to demonstrate something. So if we hit run, select current, save that. This is what the camera sees right now. As you can see, completely different lighting from what's actually in the scene. That's because we have no lighting in the game. And this is super easy to fix. All we have to do is click these 3 dots, add sun to scene, click them again, add environment to scene, and if we run it again, we now have proper lighting. So do we see what I did here? I went under this drop down and hit the 2 buttons at the bottom that appeared.
Probably fall through. No. Dots.
Sweet. Okay. So now that we have the light and the skybox added, next we are going to create the input map. And that's going to basically define what keys the player can press to interact with the game. And we're going to use this when we're programming the player. So we're going to go under project, project settings, input map, and this is how we add an event. We click on add new action. I'll name it like walk forward. Hit add. It adds the action down here. I hit the plus over here to add an input. Click on the key I want, in this case W, and click OK. And that adds it under there. I'm going to add just like very quickly all the inputs we'll need for this project and just add them, as you can keep up. But I'm going to keep these up here while I add them.
But um, I would make them an exact match what you guys. It's
The script is going to use those names.
first one is walk.
Sweet. Okay, now that we have all the inputs set, what we're going to do next is create the player object. So I'm going to add a handful of nodes here. I'm just going to add them in one shot and let you add them at your own speed. So we're going to create character body. Under that, we're going to under that, we're going to drag in the player model, Jurl.gltf. Then we're going to add a collision shape. Then we're going to add a spring arm. And then we're going to, if you haven't already added the camera, add the camera to the spring arm. If not, drag the existing one under there. And I'm also going to reset that transform. These are the nodes we're going to add right now. All good? Okay.
Is that a regular number?
I dragged in the asset onto this.
Oh, okay. The morning.
We'll fix that. So,
I think it did.
all right. So I wanna mention one thing. That file we dragged in is the model for our player. So we can actually click on this animation player and see all of the this one displays a little weirdly, but it works fine in game. We have idle. I don't know why the legs are so far down for these. In the actual game, they will look fine.
You made those.
Yeah. We're going to click on the player. We're going to pull it up a little bit. And I want to mention also when working with this, if you click directly on it, it's going to select the model. You always want to make sure to click the full player node so you move everything with it.
It actually blocked the. Make it so you don't access.
How do I do that?
There's a lock icon. On the top bar, it's a view away from the little pointer icon. Makes that a lot. It makes it.
Ah,
Select the other.
neat. Good to know.
Taught you something. Very no game ago.
All right. So we're going to rename this to player. We're going to click on the collision shape 3D. We get a warning here because we don't have a shape defined. So we're going to click here, box shape. And I am going to just kind of drag this to be about in the right place. We can use the orthographic view also to make lining this up a little bit easier.
1 second. And if you hit the arrow that will have it, that one X, like, you hit, if you like specifically where you click on the yellow arrow, it would bring it only up. So that can be a bit annoying if you hard to see type things if you're not doing one X set. And then next thing, just add a sheet. So add the sheet over to clear. This David, is doing manipulations in 3D the same as 2D where it comes up on the screen, you just drag it?
Yeah, you just drag the handles, so you have these here.
Okay, that's the manipulation shape.
Yep,
Okay, so it's okay. I think it did. I think for only moving aspect. So what I would do if I were you is go to your collision sheet. Well, first go to your block bench. Okay. Yes, and then transform. There. Hit this, and then it'll reset. It'll put it back to where it was before. And then hit this off. Yeah, that's fine. Go back. Go back. Hit this off. That will just prevent you from accidentally moving go wrong. Then, and then take checking the place here, it change. Pick this. The box bench. Okay, yeah, you got the same problem. Then reset all of it. And then put this lock. It prevents you from doing. You want to move to the parent, not the child. This is the same thing. Yeah. Then now you should get go back to the sheet. Make the new box sheet. And start. Sheet. Kind of hard to help. This needs to be over. Okay. doesn't need to be perfect, but
Yeah.
it's like a. Yeah,
Cool. Okay. So now we are going to add some behavior to this. So we're going to go under making a player whenever it wants to load.
it's you want.
That's wonderful.
Oh yeah, Bobby sent out a message saying after on.
Oh, yeah. All right. So now that we're here, we are going to scroll down. We're going to copy this script. There's a little button in the corner that can let you copy it from the clipboard. Go back to Godot, right click the spring arm, hit attach script, call it something like, what did I call it here? All right, it's just called spring arm, so we can create that. And we are going to put this in.
Didn't expect it.
And you saw where I copied the script from, right?
Are you gonna explain the script?
Yes, I'm just waiting for everyone to attach it. You know what? While people are finishing that up, let me show you what that looks like. So what this does, it adds a few things. First, we can look around. We can zoom in and out with the mouse wheel. And if we hit some geometry, the camera will adjust to not clip inside of it. So the geometry part, the collision, is just a natural effect of the spring arm. That's what it does. The zooming comes from these lines here where, okay, so let me break this down a little bit. This first line just says that this script extends from a spring arm 3D. This is like inheritance in Java. We're just saying that this is the kind of object this script gets placed on, and it gives us access to certain variables like spring length that interact with the game world. We set some constants here. The ready function is executed one time as soon as the node is ready, so this is good for setup. And here we just set the mouse mode to captured, which means that the mouse disappears and it's locked in the game window, which you may want to use for like a first person or third person game. This function gets called every time there's an input. It could be a mouse movement, it could be a key press, it could be a button on a controller, and it passes in what kind of action that was. So if the event is of type mouse motion, then we access relative.x and relative.y are essentially how much has the mouse moved since the last mouse motion, which is again something you want to use for third or first person games. We convert it from degrees to radians because it's not technically in degrees, but based on how dense screen pixels are and the fact that rotation is in radians, this is a good function to bring this into the right range. We multiply it by the mouse sensitivity we have up here, and we turn the camera on both axes by this. Can anyone tell me why we're using the X change to rotate Y and why we're using the Y change to rotate X? No? So the reason we're doing that, internet's great today, huh? Wait a minute, I have MS Paint on here. Completely forgot I'm not on Linux. Okay. So imagine this is our player. Right? They have a y-axis, an x-axis, and a z-axis. I'm actually going to color these a different color. So the y-axis is vertical, the x-axis is horizontal, and the z-axis is forward. And let's say this is the screen that the player sees. If the mouse moves this way, that means we want to rotate the player this way, right? Which means since we have an x-axis motion here, we need to rotate around the y-axis. That's why we're essentially swapping these, where we're taking the x input and we're applying it to the y rotation, and vice versa. These functions here essentially wrap around, so there's 2 pi radians in a circle, right? If we keep rotating and we end up at like 2.5 pi, this just wraps it back into that range. And then for the x-axis, since we don't want to go all the way around, we actually clamp it. So if I move my mouse up, it stops me from going all the way around. And same thing for a low angle down here. And that is what this line is doing. These two are handling the zoom in and zoom out with the scroll wheel. And then this line just clamps it to make sure you don't zoom too far in or too far out. Make sense so far? All right. Next, we will add the player, the like full player motion script. So we're going to go down on this page, copy this again. We are going to add a script to the player this time. This is a little sample script it gives us, but we're going to replace it with the bigger one. All right. So before we play, I want to real quick walk through what this script does. First thing is we have this enum. What an enum is, and this exists in most programming languages, including like Java and Python, so you can also use this in other applications. It's basically a data type that can be one of many choices. So think of it like a dropdown. I'm trying to think. Like this here. This dropdown is an enum. You can choose one of several choices. In case of the player state, the player can be idle or running or jumping or falling, but it can't be multiple of these at the same time. Like it can't be jumping and falling because jumping is going up and falling is going down, right? So we use this to describe what the player is doing. We have some constants here for speed, velocity, blah, blah, blah. Some variables to track certain things. We have, you know, current state variable that tracks the state, some things for animations. We have some references to the camera, the model, and the animation player. But let's look at the meat and potatoes of this script. So we have the process function, and this essentially runs every frame. So if a game runs at like 60 frames per second, then it's running this around 60 frames per second. But depending on how strong a computer is, it could run this faster or slower. So it passes in the delta variable, and this tells us how much time has passed since the previous call of the process function. This lets us essentially normalize the behavior. If, say, some computers are slower and some computers are faster, you don't actually want your game to run at a faster speed on the faster computer. You want it to run at the same rate. So that's what we use the delta variable for. So in this function, what we're doing is we're getting the input, and we do that. The get vector function, what we can do is give it 4 inputs, and it essentially makes like a 2D vector of like if you're holding W and you're holding D, then it makes a vector going up and to the right. W and S goes up to the left. If you're just holding like S, then it's going straight down. Stuff like that, right? Then in the direction variable, we are creating a vector where we get the X and Y axes of the input, and we're applying it to the basis. This little piece of math basically gives us a 3D vector that points in the direction that we want the player to go. We normalize it to essentially make its length 1 so we can control the speed. And we also rotate it with respect to the camera. And I'm going to show you why we need this line. But I will show that in a bit. We are also, if we are moving, we are going to rotate the model in the direction that it's moving. Notice the lerp angle function, which smooths out the rotation. This is another thing that I will show you why exactly we're doing this a little bit later. This is decently simple. If we're not moving and we're on the floor, then we set the player state to idle. If we are moving and we're on the floor, then that means we're running. If not either of these, that means we're in the air. So we check if we're going up or we're going down. And in that case, we'll set our state to jumping or falling, respectively. And then finally, we call update animation, which is a function defined further down. Here we have physics process. This is like process, but the engine guarantees that this is run at regular intervals because the physics engine needs to run regularly. So we don't want to put too much in here because the engine runs this when it's available, so we can do heavier computations. But for here, we just want to do what's necessary. So for here, we just check if we're not on the floor, then we apply gravity. If we jump and we're on the floor, then we give the player an upwards boost. If we let go of jump and we're falling, then we cut the player's momentum. And I will show you like what the impact of this line is here. And finally down here, if we're moving, then we apply that to the X and Z axes of our velocity. If not, then we set that to 0. And then down here, we call move and slide. This is like the bread and butter magic of Godot physics. Essentially, you set a velocity variable, you call this, and it just applies that velocity and accounts for collision, just works with everything with the physics engine. This makes like physics in Godot super easy. Finally, in our update animation function that we call up here, we just read the state of the player and play the respective animation. So if the player's idle, we play the idle animation. One thing to note about this is that the play function does not interrupt the same animation. So like if I play the walk animation and then 1 frame later I call this again, it will not reset the animation. It only interrupts it if you call a different animation, which means effectively we can have this running every frame and it will just loop the animations. One thing to note is that for the jumping and falling ones, we don't want the jumping and falling animations to loop over and over. We will only want those to happen once, either at the point of the jump or when we start falling. So we add extra variables to not call those again. So if we save this and if we run it, we can see, oh, that's awesome. Type null instance. Oh, we need to rename this to camera arm. And if we run that, what now? Ah, right. The model is called Journal. I forgot to rename like half of these nodes. This is in the guide. Don't worry, you won't make the same mistake if you read, unlike me. But we said all that.
This is good debugging.
What?
experience, That if something breaks, make sure all your things are neat properly.
Camera arm. Ah, this has a space. See, this is why you need to review your materials before doing a workshop.
These guys are. And look over, you're there.
There we go. And as you can see, oh, what is that? That must be a new Godot 4.5 feature because that did not happen last semester. Okay. This is where we actually go into debugging.
Yeah.
Oh wait, no, not here. Let's see if, wait, do I have to apply this? Jolt physics, save and restart. Don't do this yet. This is a debugging measure.
Then just a general that every way. See how you.
Fantastic. Okay. So Godot is switching to a new physics engine. The old one is really buggy. They're phasing it out. You have to change the project settings to switch it to the new one. So I'm gonna leave this window up for a minute. You might not have to do this also. This is different on different people's PCs. So yeah, I'll leave that up. Rename the nodes. If needed, change the physics engine.
Yeah. Oh. How did you enable collisions again on the boxes?
You click on the CSG box up here at the top, use collision.
Oh. Sure. Okay, yeah, that one's good. Maybe there's some issue. Maybe actually call David over at this point, since he's the expert.
Mhm.
Do you know how? Dave has a thing, his camera's not moving, he's falling straight through. But she was able to and work with some small beats. Yeah. Think David might be better in this product. I'm more of a 2D. I mean 2D. Yeah. Looks like a suggestion for a game platform. You can see that's my first time. Yeah, so my suggestion for the game jam would be definitely stick with Godot. Maybe not make it a 3D game. If you can find ways to minimize the amount of physics you will have to work with, then you'll get a lot further. It's like a top-down game, be good, because moving in all these directions, you don't have to worry about like velocity or force due to gravity or anything. Yeah, I didn't think it's fun, but yeah, I've done 3D because it's fun too, but it's cool. That's cool. So I guess it's up to you. If you just want to have a cool experience, you don't care about like going straight for the prize money, but then 3D is cool. If you're trying to win, beginners that have one always. Oh. Second in the first year? Oh, I'm not sure. I didn't come to the first game yet. I started coming to the second one, but then I followed one after. Oh, you don't know. That content was pretty deep. I don't know. And that's Simon's just a different piece, though. He's like a genius. But yeah, there's like a student from medical college, nursing student from Ethan, no coding experience. That doesn't work out together. One with it with all his own arms. So 2D is a whole lot easier. So it's just yeah, and you can you just made like you do something like BB that game, you know, it's a platformer where it's like reverse gravity. That was the main mechanic of this game, but it's a little what? Kind of yeah, something like that.
I'm gonna get going soon. I'm gonna bring this the whiteboard back in here.
All right. There's been, there was a games that one before that was just purely UI, no physics at all, where like, yeah, it'd be more like papers, I guess, you know, that game. That's not that game. So you can do a lot with it. Yeah. I got that games, but we're not a 3D game, though. I money what I was doing, pure 5 code. All that for ChatGPT code. That was last. I was basically like copying AI responses, thinking they would work. They never worked, and I had to I had to learn how to do it anyway. It was all. I had no idea what I was doing. It was an FPS game. You're going through hour. Rising lava. It goes on. The lava died. And they're trying to clear the tower the best you can. Yeah, that's on by the speak of my life. We're trying to figure out the 2 seconds. Yeah, that's what otherwise this one does. Just change it. Here. My first game I did for year and we the dough in broken slides. That was like 2 years ago. But yeah, I went back eventually. I got to the point where it became. And now I'm actually like formally learning Godot, doing it really good. It's all the other game jams, I'm just trying to get, well, let's get one time still. And you can win with that.
How's it going, folks?
Who has time to stay a little extra, because there's a little more content I wanna go over.
Yeah, this is all,
And it's all written down.
Sure, what, you know, you can, I mean, it's great, like, you can stay, you can come, you can go. But it is 4:30,
It is 4:30, it is the scheduled end of the workshop.
You guys all stay?
Yeah.
Yeah.
You're gonna go. That video by Clear Code, this is called our Godot tutorial.
No worries. Alright, David, you have 2 customers to stay a little bit late.
Okay.
I'm not one of them. So
Okay.
have fun. And have a lovely weekend, everyone.
I will
Forward
pull it
me
up.
the recording when it's done.
Alright,
And yeah. You're sure?
and hopefully it's not a phishing link.
Yeah. Guys, are you all signed up for the game jam? No? Do you want to?
I mean.
Alright, David, throw up the poster after.
What are you gonna be doing?
What?
Almost say capacity, so if you're thinking about it, you should just.
Yeah.
say no. And if you can't show up, then it's fine.
Yeah.
We could just move someone off the wait list.
Yeah, David will have the post and you can share that info with you. You can ask him about the game jam. He knows all about it. Oh, both of them.
If you wanna learn more, there's a video by a YouTuber named Clear Code,
Alright, I'll see you guys.
Ultimate Introduction to Go 4. It's like a whole course that's like 12 hours long, and it's really good. I watched the whole thing and it helped me a ton.
Okay,
Oh, man, I'm trying to. Oh, I think there'd be a confirmation if you signed up. Let me check that, because I'm signed up, I am competing. Sign up. Okay. I'm not sure. Let me see, I think there is, you would get an email. Okay.
If we reach out to you on Discord,
Yeah, if you reach out to Mayor, the guy who was just in here, he would know, he's the one who has access to all that. Okay.
Alright, so let's wrap this up. Couple things I want to point out for like certain lines of code. If we comment this one out, so notice how right now, if I don't change my mouth, if I don't change my camera, I can play around with WASD and change the direction I'm walking in, right? If I comment out this line and run it again, no matter how I turn my camera, like let me go back. I'm holding W. No matter how much I turn my camera, it's not going to move in relation to the camera because we commented this line out. Essentially what this does is it rotates the direction we want to go by the camera's rotation. And that's the effect of that we can turn the camera and our WASD is relative to that. The next thing is this line. So I am going to comment this out and create a different version of this where we just set this directly to the calculated angle. And what happens when we do this is now it snaps directly to the position of wherever I'm turning. So what lerp angle actually does is it will smooth out that rotation between where you are currently and where your target is. Make sense? Final thing is our animations down here. If I get rid of these conditions, so I'm just setting the animations to whatever state it is. This works fine for running and for idle, but when I jump and I fall, it keeps looping those animations. That's why we have these conditions, so they only play once and just let it jump or fall. Actually, there was one last thing. Right, this. So notice that whenever I jump, I can tap space and do a short hop, or I can hold space and do a full one, right? That's because of this line of code. If we let go of the jump button and our velocity is less than 0, which means we're falling, then we cut our velocity to a quarter. And if we get rid of this condition, or sorry, this was if we're jumping, not if we're falling, if velocity is greater than 0, then I can do this and essentially like slow my descent because I'm not checking which way my velocity is going. See how I'm kind of like doing moon gravity there? So that's why we're checking if we're going up to cut the jump. So that's everything for the player script. Would you like me to go over the remaining part of the workshop had us adding like a spike and the motor oil, and the spike is like to reset the level, like a loose condition, and the motor oil is to move on to the next one. Do you want to see that? Okay. Okay. Gotta rename this guy. His name is Gerald, that is the model's name. That actually makes everything easy. Okay. Yeah, pull the spring arm up, down the camera. Alright. Yours?
I don't know.
Yeah, the block bench export needs to rename the model, his name is Gerald, and that's what Kibel expects the name to be. So. Yeah, that, capital J. Yep. Don't run it. Oh. Well. Slow. Crash. Start. Oh, you know what? You have your camera offset from when you were looking at your level earlier. Oh. Yeah, this. How do you, oh, so, okay. We go here. We go here. Right. And we reset the transfer. Oh, there's the, oh, there it is. Yeah, that would be good. Oh, you know what? You move the model. See, this is what I was talking about. When we just click on this, we end up moving the model. Click this button. Ah, you locked the wrong one. You have to lock the one you don't want to click. And the collision shape is okay, so set that. Up. And camera arm should be a little bit up. Okay.
You need any more accessibility.
I still need the recording, so I need to go back up.
And I mean, you could stay clocked in for longer.
Okay.
My legs hurt.
Sit down.
I'm kidding.
Okay, so we had a good place. All right, let's add the spike. So what we're gonna do is add an area 3D. Under that, we are going to drag in spike.gltf. And we are going to add a collision shape. And I'm gonna drag this up, over. Pretty sure you can hit, yep, if you hit page down. So if I drag this up, if I want to like line it up with the ground, all I have to do is hit page down on my keyboard and it snaps it to the floor. We're gonna go here, add a shape, box shape. You know, what I'm gonna do is go here. All right. So we create an area 3D, we add this, we add the collision shape, and I'll call this a spike. Ready to move on? All right, we are going to add a script to this. That's going to be under 10.3. That's going to be this one up here. So what this does is collision is a function that gets called whenever this collides with something, and it gives us whatever it collided with. We check what the name of that is, and if it's player, then we reload the scene. And if I run this and I walk into the spike, you'll see nothing happens. That's because I lied. This doesn't actually get called. This is just a function that I made up because there is no function on an area 3D that tells you if it collided with something. What it has instead is a signal. So if we go over to the node tab, if we click on the spike, it has a bunch of signals. And what a signal is it's essentially an event that it's like a message that gets sent off anytime an event happens. So what we need to do is link the correct signal to this function. In this case, we want body entered. Double click this, scroll down to the spike, hit pick, and choose the function we made, collision. And we can see there's a little icon that goes to collision, and there's a little thing here that means this is incoming from a signal. And if we walk into the spike, it resets the scene. So in here, you probably don't want to immediately reset it. You might want to do a game over screen or something. But also, notice we're doing this weird call deferred thing. So what happens if we directly call get tree dot reload current scene? It works, but we get an error. it says removing a collision object node during a physics callback is not allowed and will cause undesired behavior. Remove of call deferred instead. What this is basically saying, so Godot has something called a scheduler where it will run different tasks at different times. So for like a couple milliseconds, it might do rendering. For another few, it might do physics. For another few milliseconds, it might pull the input system. But when certain stages are happening, there are certain rules you have to follow. For example, while physics is happening, you cannot modify the node tree. Like you can't change what physics objects exist. You have to do that between the physics cycles. Since collision gets called on the body entered signal, this happens during the physics cycle, which means if we reload the scene, we're effectively destroying the node tree and rebuilding it during the physics cycle, which is where we're getting that error. So what we do instead is we use the call deferred function, which basically says call this when it's safe to do so. Call this when the object is idle and we're not in any like processing stage. So that's how that works. Does that make sense? How to get the what? All right. Now we are going to add the motor oil. Oh, actually, before we do that, what we're going to do is click and drag the spike, and we're going to drag it into the file system, and we'll save this as spike.tscn. And now what this lets us do is it lets us bring in as many spikes as we want without having to recreate the object every single time. And the best part is if we want to modify it, we only have to change the original, and the update applies to all the ones we've already placed. So that's a powerful thing. In Unity, this is called a prefab.
Unity. No.
Yeah, well, people have heard the word prefab probably.
Yeah. Feedback.
Are we ready to move on to the final thing? On body enter. Area entered is for a different area going into this area. Body entered is for a physics body, like this is a character body, for example. If you were like detecting a rigid body, you would also use body entered.
I should know this. I've been using it for 2 months and I still get it mixed up.
All right. Let me know when we're good to move on. Yeah, you can't leave yet, River.
We still have the. So that. Okay, so actionable. That's. Right. Body shape enter. So I think the naming. No, it's just body. For sure. Oh. In the X. On. Active. Spike. Then. That. over. Just follow the food. Oh, it's hard. That no needs to be named player, but. This is checking for. Yes, that one needs to be named player with effort, just the way it's. Normally, what do it? Do it's, and just have like a separate player. Okay.
Okay, final thing. So we have our spikes.
I'm gonna head out.
Alrighty,
See ya.
we're going to create a new area 3D. We are going to drag in the motor oil. And we're going to make a collision shape. Pull this up and over. Fit the collision. Doesn't have to be exact. I'm gonna use this view here to make it a little bit easier. We're ready to move on?
Yeah.
All right. Just let me, sorry, I was depending on River to tell me because there were a handful more people, so just let me know when we're ready to move on from each step. Rename this to. Where's rename? Yeah, whatever. I'll call this win. We get the script from down here. Thing. Attach script win.gd and put this here. So this is similar-ish to the spike one. We're detecting a collision. Oh yeah, we also have to set the signal for this one too. Body entered, go down to win. I need to save the script for this to show up. Go down to win, connect collision. And we have this here where instead of resetting the scene, we change the scene to a different one that's specified up here. We have this here, and I'll show you what this does. It makes the oil can bob up and down like an item. And we just use a sine wave for that, where we just spin it around. Well, we rotate it by a speed here for the y-axis one, and then we just bob it up and down with this. Final thing is for the win object here. Notice I have an export tag on this variable. That means it actually shows up here, and I can set it to something. So if I create a new scene, I'll call it level 2, and I'm not going to actually put anything in here. I'm just going to text, or no, it's going to be a label. Do that. And then if we, where's the level 1 scene? Go back to the win canister. Drag, no, this is the script. Where's level 2? Here. Drag this in here. We interact with this. I hit the spike. We go to the UN scene. And the benefit about export variables is, let's say we do this, and we drag another win canister over here. Oh, you know what? I made a small mistake there. I'm going to get rid of that. I'm going to have nothing in here, and then I'm going to turn it into a prefab. So now, if I drag a second one out here, if I make this one level 2 dot scene, and I'm gonna duplicate this, make it level 3, do that, add a 2 onto that. So we can make one of these go to level 2, and then one of these go to level 3. So if we go to the first one, says you win. If we go to the other one, it says you win too. And the point I'm trying to make here is that even though when we make this, all of the objects have whatever you define in here, and where if you change this in one place, it reflects in all of them, exported variables don't follow that. So you can make something, an exported variable, make as many copies and have different properties for each one. So one goes to one scene, one goes to the other. Make sense? That is all I have for the workshop.